Hi, this is your Sabin Bhartiya, and welcome to another episode of State of Energy. We are here in Paris for LF Energy Summit. And today we have with us Frederik Stoel, member of TSC at OpenSTEF and also data science engineer at Alliander. Frederik, it's good to have you on the show.
Thanks for having me.
We have covered OpenSTEF project earlier as well, but I want to always refresh the memory of our viewers. What is the project all about?
OpenSTEF is all about forecasting and forecasting energy. So especially the power load for the short term, so like up to 48 hours in the future.
Can you talk about the importance of this kind of forecasting in today's world? Also, we have to look at the whole energy sector has evolved. It's no more electrons are flowing from distributors to consumers. We also have solar roofs. We also have electric chargers. We also have batteries at home. So we are kind of becoming producers as well. So talk about this change dynamics of the whole electric industry or market. And then what is the role of forecasting there?
First of all, the forecasting becomes more difficult, just as you mentioned, because there's all these dynamics going on where even the small customers become producers. So the load profiles themselves become more difficult to forecast. But it also means that it's more important to forecast. And the reason is that our assets, the assets of the grid, become more, well, the demand of electricity is growing. And not only the demand for use, but also to produce, as you've said. And this means that our assets are getting more load. And well, to make the most of these assets that we currently have, forecasting is actually very essential. Because if you can see a problem coming, so if, for example, you know, okay, tomorrow there's going to be a problem on the grid, then you can, well, try to use all kinds of solutions to solve that issue. So that's an essential thing of forecasting for a grid operator.
When we talk about grid, we are also talking about microgrid a lot these days. First of all, can you define how do you use, because everybody defines microgrid in their own definition. How would you define microgrid, and if forecasting can play any role there as well?
How I see microgrid would be some party, and so from the perspective of a grid operator, it might not really matter how the microgrid looks like, but we see it as something happening behind one common grid connection. And the advantage for a grid operator would be that if a microgrid is able to balance itself, then it would need a lower maximum capacity towards the national grid, which means that we could connect more of those microgrids or more customers towards the national grid. And I think forecasting is important for microgrids because if they can accurately forecast and tell the grid operator, hey, this is what we expect that we need to use, then we can provide that exact capacity to them by using dynamic contracts or other constructs.
Let's go back to the whole traffic, when we look at, going back and forecasting. There are two, and I'm not an expert in this field, but there are two cases. One is nobody is using it, so there is surplus of energy. And second is that everybody is using it, so a lot of congestion is happening. So when it comes to forecasting, and also if you look at this specific project, which is the problem area that you see is more critical?
I think the answer is that both use cases are actually quite important. So we see both. There's places in the grid where really the generation side is a problem. So as you said, on a sunny day, well, we see that some asset might get into problems because there's too much generation going on. And there's other places in the grid where the consumption is actually a problem because, I don't know, people want to use more electricity, especially industries. But actually, recently, we also see that there's points in the grid that have both problems. So during certain areas, like, for example, when it's very windy or something, then there's a problem on the generation side, and then if there's no wind and there's no sun, then suddenly there's a problem on the consumption side. So that actually makes it even more difficult. And since there's like you have those two problems at the same spot in the net, and I think some of them are also easier to use or to solve. For example, for consumption, it's much harder to solve in the sense that if you have a generation problem, you can ask a solar farm, okay, please do not produce as much energy by maybe like disconnecting them from the grid and then paying them for compensation. But if you have a big factory, then it's much harder to say, okay, please don't produce as much products because, that's what they do and that's what they expect to be able to produce. So I think like solution-wise, the consumption problems are maybe more difficult to fix. But when you look at the forecasts, I think both of them are equally important to remember that you have you have both of these problems and you have to take them both into account all the time.
Can you also talk about what kind of community you are seeing around OpenSTEF project?
I think mainly the current community we see being interested in OpenSTEF are grid operators at the first hand. This makes sense because obviously they have the same problems as we at Alliander have, and OpenSTEF can help solve those issues. And other parties that are interested in OpenSTEF are also certain larger companies that also have these problems. For example, like as we talked about earlier, in a microgrid scale. So for example, we have this large compound or campus, and you have like multiple buildings, and you have some renewable energy and some storage. There maybe OpenSTEF can also provide insights in what's going on there, and that's also where we have some collaboration with a party who is doing that.
What is the next challenge, or what is the next area that you're like, where is the project heading? What is the next problem that you're trying to solve for the project?
The project right now is in production at Alliander. We're trying to improve in certain areas. So, for example, one of the areas we are really trying to look into in more detail is, for example, okay, how can we, if we have some load somewhere in the grid, how can we disaggregate this load into, for example, wind and solar, like in these parts. We have something for that, but yeah, we right now we're looking into, hey, how can we improve this? And another subject is, for example, okay, you have for forecast in the grid, so you have like on all these points. You have forecasts, but now how can I combine these forecasts into more insight into the grid? So like, for example, I can simply add them together, but is that the best way to do it? Or is it maybe better to add them together first and then make a forecast? So these are some research questions we're currently trying to answer and to improve the product.
No, of course, these are all open source tech projects. But the thing is that we are looking at a much bigger picture. And I used to talk to Shuli Goodman all the time. We talked about the much bigger problem, which is climate change. And even if you don't realize, if every small bit helps with that. So can you also talk about how these smaller projects, without realizing, help in contributing to fight this bigger challenge ahead of us?
I think especially forecasting could help. In somewhat of a long way around, but maybe it can help fight climate change, because forecasting is important to figure out what type of energy source will be available tomorrow. So if we know, for example, okay, we have a lot of solar energy tomorrow, then certain companies that care about climate change can actually act on that. So, for example, if you have a big factory that produce that uses ovens to make some type of food, then they might change their production by saying, okay, right now we can turn on their heaters at like at 12 o'clock in the afternoon, because then there's a lot of solar energy and then it's green. And maybe at night we should hope that we don't do it. So these are, I think, impacts that forecasts can have on really trying to also reduce like carbon emissions.
Frederik, thank you so much for taking time out today. Of course, talk about OpenSTEF project and also talk about the larger picture as well. And as usual, I would love to sit down and chat with you again. Thank you.
Thank you for having me.